So we did this as a whole class, and it has an activity as part of it. So we're not really going to do that activity right now. But I just thought I'd record the notes so that those of you who weren't here can watch them, and that would help you with class. What we asked you guys to do is figure out the distance between these 2 points without a ruler and be able to justify or explain your answer. So people came up with all sorts of different numbers, and the most common correct-ish one was that people went across this way and they counted 1, 2, 3, 4, 5, 6, 7, 8, or up this way, which was 6. And that's actually a good way to start. This forms a right triangle, and some of you have learned in the past about the Pythagorean theorem, a squared plus b squared equals c squared. And then you would just plug in your stuff. C is always the hypotenuse, the longest side. And that's what we're looking for. So people did 8 squared plus 6 squared equals c squared. And solved it. 64 plus 36 equals c squared. 100 equals c squared. And you don't have to copy this, by the way. And then did the square root of those. So 10 equals c. So the length of that side is 10, which is right. But you're not always going to have points that are so easily graphable. And so there's a shortcut formula that looks long, but it's not bad, called the distance formula. It's a version of the Pythagorean theorem, but I'm just going to show it to you and then show you how to use it for now. And if you have more questions about how it comes about, I can show you those later. So it's basically the same thing in the last form. Distance equals the square root of x minus x squared plus y minus y squared. Oops, that's it. I was in the wrong spot. Sorry. All right, so you can do your x's and y's in either order. That's why I didn't put the subscripts on there, but some people might be hardcore about subscripts, and that's okay. So in this problem, you would find those coordinates and plug them in, but I'm really going to show you how that works more on the next page than here. For now, just know that you need to memorize this formula and be able to use it. The other part is that there are keywords that show that you need to use the distance formula. Obviously, sometimes it will say distance, but it will also say how long or length. Sometimes how far. Anything that indicates you're going to need a distance, you're going to use the distance formula to figure it out. So on the next page, I'm going to show you how that works. How long, see how long, is this segment? We're going to use distance equals the square root of x minus x squared plus y minus y squared. So our coordinates are 3, 4, and 4, negative 4. These are our x's, the first coordinate, and our y's. Make sure when you use the distance formula, you're actually putting the x's together and the y's together instead of a coordinate together. So x is 3 minus 4 squared plus y's 4 minus negative 4 squared. So the x's were the yellow numbers and the y's were the pink numbers. And I'm going to zoom in more. There you go. Okay. Maybe one more. All right. Minus and negative is a positive, so I'll change that, and then we just go through. So 3 minus 4 is negative 1 squared, plus 4 is 8 squared. 1 squared, negative 1 squared is 1, and 8 squared is 64. So the distance is the square root of 65. Now, that doesn't really give you much to visualize, so you kind of want to see approximately where that is, that value is. And there's a couple ways to do that. First, this is the exact answer. Ideally, we would want to simplify the radical. 65 is 5 and 13, I think. Yeah. So this actually is the simplified radical. And then you can also express it as a decimal by putting in the calculator the square root of 65 and writing the rounded version. Those squiggly equal signs mean approximately 8.06. Because we rounded, it's not exact. And that is how you find the distance. So we're going to do it again. How long is the segment between these 2 points? How long means distance. Distance equals the square root of x minus x squared plus y minus y squared. And when we were in class, I was talking about how the distance formula is not a stripper. It does not like to be naked. So please leave the radical on the distance formula the whole time you're working with it until you get to the end and you actually use the radical. All right, so we need to plug in our x's, which are 2 and negative 5, and plug in our y's, which are negative 7 and 3. So the square root of, let's see, 2 minus negative 5 and negative 7 minus 3 for the y's. This becomes plus, so 7 squared plus negative 10 squared. These parentheses matter. Leave them on until you're done squaring because it will affect the value. Negative 10 squared is 100 minus 10 squared without the parentheses is actually negative 100. So this is 49 and 100. So the distance equals the square root of 149. 149 is a prime number, so you can't prime factor it anymore. This is simplest form. But we can approximate the decimal. The square root of 149 is about 12.21. That is how you use the distance formula. At this point, you should be like, I think I might get this a little bit, and you should be able to attempt one on your own. I would recommend that you try this next example on your own, and I will come back in another video and show you the solution. Keep in mind you are only looking for the distance of that blue line.